In this video, we will be graphing trig functions when our angle is in radians. There are a lot of similarities between graphing in degrees and radians, so let's start off by looking at our general equation. So our A value here represents the amplitude, which is half of the distance between the max and min, or the distance from the maximum to your central axis or midline, or the minimum to that midline. Then we have our C, which is the vertical shift, the up-down. This represents your central axis or midline. And together with your midline value and your amplitude, you can get your maximum and your minimum. Because from your midline, you can add the amplitude to get your max, and from your midline, you can subtract the amplitude to get your minimum. Your D value, which is your right-left movement, we call that our phase shift. It's going to give you your starting point for your first cycle. Now, your starting point is also going to depend on if you're graphing sine or cos and if it's reflected or not. So as a reminder, when you have a positive sine function, and by positive I mean the A value is positive, we know that we start at the midline and we head upwards to the maximum. If our sine has a negative in front, that means that it has been reflected over the x-axis, which means we're still starting on our midline, but instead of going up to our maximum, we're going to go to our minimum and then continue our wave. If we have a positive cos function, your starting point is up at the maximum and then hitting all of your lines to create your wave. And if you have a negative cos, that reflection will create a starting point at the minimum. So using the D value, if it's sine and cos, and the sine of A, you will get that start. Finally, your K value, which represents your horizontal stretch or compression, is going to help you find your period. Now, back when we did everything in degrees, we would take our original period of the base function, so 360, and divide it by k. And that's because the k value we see, the stretch or compression factor, is actually the reciprocal. So 360 times 1 over k, that reciprocal, results in 360 divided by k. Now that's the degree way. But we're not graphing in degrees anymore, but we do know that 360 degrees is equivalent to 2 pi. So our base function of sine and cos, the original period is 2 pi, and if we divide that by k, we get our period. So if you know your starting point, a period later is going to be your ending point. Now, to help you graph, I like to find my key point, or my critical point, how often you jump from your maximum to your midline to your minimum and so on to create that wave. Our key point occurs a quarter of the period because we have 4 quadrants and your key points occur at every 90 degrees. Every 90 degrees is 1 quadrant. So what we're going to do is take our period and divide it into 4 segments, and that will tell you how far apart your key points are. So let's take that and apply it to our first function. We have f at x equals negative 2 sine 3x plus 2 pi plus 3. First thing, we know our k value has to be factored out. So that's the first thing I'm going to do. And that just means we're dividing 3x by 3 to get x, and we're dividing 2 pi by 3 to get 2 pi over 3. Now, I know that my midline is going to be at 3. So I'll draw that in. I know my amplitude is 2, which means my maximum is going to be 2 above, so at 5. And the minimum is going to be 2 below, so at 1. And now we have boundaries as we create our points in our function. Now the phase shift is 2 pi over 3, and we're going to the left. I'm not going to apply that phase shift to draw my starting point just yet because I don't have a scale, and I have to take my period and my key point into consideration to create a nice, clean, helpful scale for my graph. So I know I'm going to start left 2 pi over 3. I also know I have a reflected sine function, which means I'm going to be starting on the midline, heading down to the minimum because it is a reflected sine. And let's get our period, and then we can actually start graphing. So for our period, I'm going to take my original period of 2 pi and divide it by my k value, which is 3. So here's my period. And my key point, I'm going to take my period and divide it by 4. Now a reminder, dividing by 4 is the same as multiplying by a quarter. Our key point is 2 pi over 12 or pi over 6. So I'm going to need a scale that allows me to hop max, mid, min every pi over 6 radians. And I also need to be able to shift left 2 pi over 3. The best scale is going to come from a common denominator between the 3 in your phase shift and the 6 in your key point. So between 3 and 6, a common denominator is 6. A scale of pi over 6 would be ideal. So I'm going to go ahead and label that. One box is pi over 6. My second box, we're just adding on another pi over 6. That would be 2 pi over 6, which we can, of course, reduce to pi over 3. Now I'll just put a little side note here to see that simplifying. I would not write that 2 pi over 6, but just for reference. I'll erase it later. This third box will be 3 pi over 6, but that, of course, 3 over 6 reduces to pi over 2. The fourth box will be 4 pi over 6. 4 over 6 is 2/3, so 2 pi over 3. The fifth box will be 5 pi over 6. That can't be reduced. The sixth box would be 6 pi over 6. That, of course, can be reduced to pi. Now I'm on my seventh box, 7 pi over 6. I'm on my eighth box, 8 pi over 6, and 8 over 6 reduces to 4 pi over 3. Now I'm on my ninth box, 9 pi over 6 reduces to 3 pi over 2. 10th box is 10 pi over 6, which reduces to 5 pi over 3. The 11th box will not be reduced, so 11 pi over 6. And the 12th box, 12 pi over 6, is 2 pi. So there is my scale on the positive side, and it would be the exact same numbers on the negative side, which I'm not going to write, but they're the exact same thing, but the negative versions. And now I can start graphing. We've already established that we're starting 2 pi over 3 to the left, and if I look at my scale here, 2 pi over 3 is 4 boxes away. So if I want to go to my left, I'll just go left 4 boxes and plot my starting point. Here we are. There's negative 2 pi over 3, if I want to label that. And I know I'm going to head downwards to my minimum because it was a reflected sine, and I'm doing that every pi over 6. And because we chose a smart scale, one box for us is that pi over 6. So every one box, I'm going to hop lines to create that characteristic wave. So here's my first cycle. And now I can continue my pattern, just hopping lines, every pi over 6 or every 1 square, and then I can connect. And same thing to my left. If you're given a big grid, use the whole thing. Now I could have spaced this out a little better so that my scale wasn't so overwhelming. Maybe I could have said instead of 1 box is pi over 6, 2 boxes is pi over 6. I would still fit plenty of cycles. And there we go. There's our first function in radians. Almost identical, only difference is we have that 2 pi instead of the 360 to get our period with the 2 pi over k. So let's try one more example. 3 cos 2x plus pi minus 1. Of course, step 1, factor out the k. We're factoring out the 2. That's going to give us x plus pi over 2 minus 1. Okay, my midline is -1. My amplitude is 3. So 3 above takes me to 2 for my maximum. 3 below takes me to -4 for my minimum. I also see that my phase shift is left pi over 2. We have cos, which means we're starting at a max. Because it's a positive cos, it was not reflected. And finally, I need that period. So 2 pi over my k value, k is 2, so the period is pi. For my key point, we take that pi and divide it into the 4 quadrants, 4 segments. So pi over 4 radians apart for those key points. So now when I'm picking my scale, I'm looking at my key point, I'm looking at my phase shift, the denominators are 2 and 4, pi over 4 would be a great scale. And you know what, this time I'm gonna do every 2 boxes is pi over 4, so the scale doesn't get as cluttered. So here's pi over 4. This next one would be 2 pi over 4, but 2 over 4 reduces to pi over 2. The next block would be 3. I'm on my third set, so 3 pi over 4. The next one would be 4 pi over 4, but 4 over 4 reduces to a nice pi. The next one, I'm on my fifth, so 5 pi over 4, and the last one, 6 pi over 4, which reduces to 3 pi over 2. And because this one's a little cleaner, I'll do the exact same thing on the negative side. And now we can go ahead and start graphing here. We're going to shift left pi over 2, and we're starting at the maximum. Here we are. And our key point is pi over 4. That's 2 sets of boxes for us. The only place we can go from here is down, down again. Every pi over 4. Now I'm going to go up, up. There's my first cos cycle. And I'm just going to continue with my same pattern, hopping those 3 important lines every pi over 4, which for my scale is every 2 boxes. And there we go. There's our cos function. So again, we want to use our midline, draw that in, use the amplitude to help you get your max and min, identify your phase shift, and if you have sine or cos, if it's reflected, to get that starting point. Do 2 pi divided by your k to get the period, and then you can divide that period by 4 to get your key point. And your scale comes from your phase shift and your key point. If you have a good scale, drawing those points and connecting the dots becomes really quick and easy. But if your scale isn't nice and useful and clean, it's going to be messy and not very accurate.